video is created in order to let any user to further understand and to follow the steps. This video also teaches you how to use the various calculation functions within various spreadsheets. Okay, first thing first, what we have here is the interpolation calculation spreadsheet. Here allows you to find the unknown set, which is the values that you may want to interpolate, and to get the rest of the data for this set of values. So what we have here, for example, we can give a 33 degrees in temperature, and what you may have seen over here is the various errors messages here, this column of this cell. What happened was that because the range is too far, the error message prompts you to choose a nearer value. In this case, since I have an unknown set of 33, so I would choose a closer value to 33, 32, and here the warning message is off. It's because it's already within the range. And for the next value, I will choose slightly higher, which is 34, and all the warning messages have been switched off. In this case, once there is any warning messages, this is the value set that you are looking for. Okay, next we have a simple cycle calculation. Over here we have a picture illustration for you to understand where this value actually meant at which area. Since at this moment we have condensing value of 50 degrees, which is at this point, at this line, and a evaporating value of minus 16 degrees Celsius, which is at this line over here. So after you have selected the required temperatures value for this particular cycle, the spreadsheet will automatically do the calculation for you and end up giving you this coefficient of this refrigerant, which is the value that which we are looking for, since it shows whether how efficient of this refrigerant works in this particular cycle itself. This is a demonstration for a simple single cycle with interpolation. It works similarly with the previous simple single cycle, where the condensing and the evaporating temperature point we have to be selected. Let's say we have a temperature that we want is minus 15 degrees. It prompts change of values. And what's the reason for prompting the change of values? Is because these two values are not within the interpolating range. So what we can do is that we can change this minus 18 to minus 14 degrees set, and that settles all these data to be used. So what happens if we choose a value that is too high, like say for example minus 45, it will prompt you to choose a nearer set of value, which is quite similar to the interpolation method. So I'm going to change these values back to minus 16 degrees, and there's no warning, any warning messages, so these values is valid. We shall leave this condensing temperature at the 50 degrees Celsius. Okay, and the rest of the formulas will be automatically generated, and this is the value we are looking at for the efficiency in making a decision whether this is the right system to be used or not to be used. Okay, over here we have a demonstration of a simple dual cycle. Basically, dual cycle meant that a flash chamber is being introduced within the cycle. That's the reason for the dual cycle, as it seems to have two single cycle being stacked on top of each other. That's the reason why it's being called a dual cycle. Since that's the case, we have additional function of this table here, which is meant for the flash chamber. So apart from the previous evaporating and condensing selection of the value, temperature value, in addition we have to select a value for a flash chamber, and once the value is being selected, the rest of the workings will be done automatically. This is the coefficient of performance of the refrigerant in this system. Basically 3.2 is quite a high ratio, therefore this system is able to perform 3 times of what is required. Okay, what we have now is a simple dual cycle interpolation, meaning that there's an interpolation involved for this dual cycle system. And here we have an additional feature of this flash chamber, which meant on this line. So how it works is very similar as the previous interpolation that we have done. For example, the flash chamber, we have a 5 degrees temperature, then the error message, and this is the reason. The temperature range for interpolation wasn't a desirable set, and after modifications, the warning messages disappears, and this is the set of data we will be using, and all the formulations will do the calculation automatically. And this is a value where we are looking for coefficient of performance. How well does this refrigerant perform? There's a data source for the set of values being selected, and should you have the requirement of adding more data to increase the range, this is the table where you can actually increase or add in more strings of data. As of this moment, this set of data only ranges from minus 50 degrees to positive 50 degrees. And that's all for this demonstration of video. Thank you very much.